So what is called index? So index is a entries that we are going to search a particular value that is smaller than the original file. So these are called as a index files. Okay. So there are two kinds of indexes. One is ordered index and another one is hash index. Okay. So in ordered index, what we are going to do is we are going to search all the search the keys in a sorted order. Okay, that is ordered index. Search the key in a sorted order. Hash index, we are going to distribute across uniform keys. Okay, so example, there are a different set of buckets. So you know what is called buckets. In that the data will be stored, or whatever the queries or whatever the issues or whatever the scenarios are there, it will be kept as a bucket, and at a particular time these buckets will be solved within the period of time limit. Okay, so this issue can be handled by the hash index. Okay, so one is ordered indices and hash indices. So hash indices are going to use the hash function. Okay, so this will surely come in a MCQ. Next, so ordered indices. So ordered index, we have a index entries. So what is called index entries? For every record there will be an index 0 to 1 in a sequential order. That's why it has primary index as well as secondary index. So primary index will have a sequence order 5. Primary index will have a sequence order 5. So secondary index will have a order different from the sequential order. So it will be somewhat different from the sequential order, but it has dense index and a sparse index. Okay, so it has a dense index as well as sparse index. So based on this, we have a set of scenarios where we have seen the indexing and the hashing. Now in ordered index, we have a random access. So random access in the sense how this sequential order is going to take care based on primary index. So primary index otherwise is called as a clustering index. Okay, they usually clustering index will be used by the primary index. We have seen previously. Now this is actually it's a necessary. Why? Because a primary key is usually it's not it's actually going to search the key for a particular concept or a record, right? So here dense index 5. So what is called dense index? So this particular record is going to appear and search the key value in the file. Example, Bridgestone. So here the Bridgestone is there. So it's going to search the key value for that particular file. Okay. So next is sparse index. So sparse index, so it contains index records. So where is this? These are the index records. But in case of a particular Bridgestone, so example, so it is the going to find index record with the largest search key value. Going to find the index record with the largest search key value. So based on the largest search key value, which is less or equal to that search file, it will search that record, and this record will be found. Okay, right. Next, multi-level index. So multi-level index treat the primary index as a sequence file. Okay, and it has outer index and inner index. So what is called outer index? This is a sparse index of the primary index, and the inner index is a primary index of the outer index. Okay, so this is the main difference. Outer index is a sparse index of the primary index, and the inner index is a primary index of the outer index. Okay, so this will surely come in the MCQ, right? Right. So this diagram already you have seen. Since the outer index is a big block, that block can be further in the inner index. It can be subdivided, and again the data can be checked in different data blocks. Okay, so these things we have seen in the yesterday's session. Okay. Now, so we'll see ordered index. That is what is called index, ordered index, and primary index. So that's a small version where we are going to see a type of index where it is going to be applied. So index and hashing. So what is the basic concept in this one? Index is a mechanism that is used to speed up the access to desired data. How to speed up? Based on the lookup of the particular records in a file. Okay, so it is called index entries. So this index file is otherwise called as index entries. Okay, so as we see, there are two basic things for indices: ordered indices and hash indices. So in ordered indices, we are going to search the stored value of the key where using primary index as well as secondary index. So primary index is a sequential order form. Secondary index is a order from the sequential order. That is, it is different from the sequential order. That is, dense index and sparse index are the sub point for this particular secondary index. Okay. So again, we are going to check with the particular indices where we can have here a different set of order indices using a sequential order. Okay, so now we will have a small session where we can check with what is called index, what is called a primary index and secondary index. Okay.
Hi students, coming to our next topic, that is indexing. Actually, indexing is a way of optimizing performance of a database by minimizing the number of disk access required when a query is processed. So whenever you ask a query and a query is processed, this indexing is helped to minimize the number of access required. Okay, so whenever a database query is processed, this indexing is helped to minimize the number of disk access required. So here the indexing is a way of optimizing the performance. It is a way of optimize the performance of database. Okay, so this you call it as indexing. So let us see what is an index. Index you call it as a data structure. Okay, index is a data structure which is used to quickly locate and access the data in database table. So that you call it as index. So index is nothing but a data structure value. So which is used to quickly locate and access the data in database table. Suppose if you take your textbook, if you want to see the topic of about clustering, okay, clustering, or else you want to see about the primary key, okay. So if you want to know about the primary key, you just open the textbook. Open textbook. So instead of going to search each and every page, you just go through the back side of textbook. Index will be there. Okay, so you just open your textbook, and backside of your textbook an index will be there. So in that index you just see the primary key, and they give the page numbers, page number 20, 37, some suppose like 128. In all these pages primary keyword will be there. Okay, so in 20 they said the definition will be there in 20 page. So instead of searching the all book, you just open the 20 page and you'll read about the primary key. This 20 you call it as an index value. Okay, key value, search key value. So in that particular location, whatever you want, that file will be there. In the same way, in the database also, if you want to search for a particular record, with the help of index, you will directly go to that, means the processor directly go to that particular index and it take that value, take that record. Okay, that you call it as index. So let us see the structure of index. Structure of index. So in structure of index consists of search key. So in the first left column you are having the search key, and this right column you are having data reference value, means the pointer value to where you have to go for the particular search key. Okay, location, data location. So the structure of index consists of search key and the data reference. So what the search key will do? Okay, search key will contain copy of primary key or candidate key of a table. So in a database table, the search key is nothing but it is maybe a primary key or a candidate key of a table. Whereas data reference contains set of pointers which holding the address of disk block. So it holds the address of particular disk block, suppose B1, B2, like that. So particular disk block address will store in the data reference in that disk block where particular key value can be found. Okay, if you search in that particular disk block, you will find the whatever the key value that we are searching. So this is a structure of key. So it consists of the search key on which item we are we are searching for that particular data item, and the pointer to the data item. So in that which location maybe nearer to that particular key is present. So this is a structure of index. Here data is stored in sorted orders. It doesn't show, okay, it doesn't, the data may or may not be stored in the sorted order. In some cases it's stored in the sorted order. If you use the another different types of indexings will be there. So in particular indexing structures, a sorted order will be necessary. In another type of indexing structures, it may or may not access the use the sorted order. Okay. So let us see one example how this indexing will be allotted in the database table. So let us take, suppose this is an index key structure. So it's having the set of records will be there, and suppose this is the index. So index what consisting of the search key will be there, and the data reference, you call it as a block pointer to where the data, the search key will be present, a particular block pointer. Okay, so and here blocks will be there. Okay, So in particular, suppose the search key 1, it may be in first block pointer. So up to 1 to 10 it presents in block pointer 1. And suppose if search key 11, block pointer 2. Means another 10 records will be present in block pointer 2. Block 2. From 21, block 3. So like that up to suppose 91 is for B10, 101 is B11, 11 is B12, 121 is B13. So like that it's the index consisting of the search key and the block pointers. Okay. Suppose here you are having different blocks. This is one block pointer and this is another block pointer and this is another block pointer. Like that different blocks will be there. Okay. So here if you want to search the value, the search key is suppose 120. So in the particular 120 record you are having the data item. So what it does, the database it goes to nearer to that. So 101 means it is in up to 101 to 110 it is in block pointer 11, means in the block 11. Okay. So block 11 consisting of 101, 102, 103 up to 110. Okay. Next block 12 consisting of 111, 112, 113 up to 120. Okay. And the block 13 consisting of 121, 122 up to 130. Okay. So this is block 1, block 2 up to like that. So here the search key is the 120 is the search key. So in that 120 we are having the data item which it is searching for. Okay. So 120 means in which position, in which block that 120 will be stored. So this is 111 and here is 121. So in block 12 maybe the data is present. So it points to block 12 and searching for the particular value, and there you find the data item which you require. So here total how many searches will be there up to your search the data items blocks up to 11 searches. 11 blocks you searched here. Okay. So this is how the index will help. Instead of searching for each and every record 1, 2, 3, 4 up to the search value is 120. So this is block 1 and block 2, block 10. Block 2. So like that block 4, block 5, block 6. You are searching for each and every item in the block until you go for 120. Okay. So here 120 means it's totally it has to search all the records in each and every block. So this is a normal procedure. So if you use the index, it helps with the help of the search key and with the help of the base pointer. It directly goes to that particular block, and this particular block it goes to directly that particular record. Okay. So this is the use of index, which helps to minimize the searching devices, searching points. Okay. Thank you. Students, coming to our next topic, that is primary indexing. So this is one of the indexing technique that is mostly used in the database management system. So let us see what is this primary indexing. Primary indexing, I already said, it is nothing but it is a primary key. The primary indexing is combination of primary key and it should be the ordered data. So whatever the data that we are accessing, that should be in order. So that is the main thing here you have to note it. In the primary indexing, you have to know the primary key of your database and your table, and it should be whatever the data that is means the database is accessing, that should be ordered. Okay, so it is an ordered file whose records are of fixed length. So, and one more point is it is ordered file and whose records are of fixed length size. So all the records that are present in the table, okay, in the file, that should be a fixed length size and with two fields. It is having two fields. So first field you make it as a primary key, okay, and the second field is the pointer to data file. Okay, so I already said the index structure. So the index structure consisting of the search key, okay, that you call it here, you taking as a primary key, and the pointer to the data field. So this is the structure of the indexing. So if you take it a primary indexing, the search key should be a primary key and the pointer to the data field. So to which block we are searching, so that related address will be stored in this pointer. Okay, pointer field. This is about this primary index. So primary index consisting of primary key and the data that should be accessing in the tables, that should be in ordered data. So here index entry is created first. Record of each block, you call it as a block anchor. So for whatever the index entry is created for first record of each block called as block anchor. Okay, that you have to be noted here. So here the index entry is created. So this is an index entry. So whatever the index entry is created for first record of each block. So here the records are there. Suppose this is the block data file. So in the data file, you are having blocks. So in each block you are having records. So here the index entry is created. Okay, index entry is created for the first record, only to the first record of each block. Okay, so the index entry is created only to the first record of each block. So this block entry will be stored here and this block entry is stored here. Okay, this will access. So we are not creating for all the records. Okay, only to the starting record of each block index entry is created. This you call it as a block anchor. Or you get it? So the block anchor is nothing but an index entry is created for first record of each block. This you call it as a block anchor. So I will clearly explain by taking the example. So that you call it as a block anchor. And another point is in the primary indexing, number of index entries is equal to number of blocks. Okay, first here I am explaining all the points. So what we are using in the primary indexing. Later we will take the example and we will discuss about these points in that example. So here the first point is, I said it should be a fixed length size and with two fields. One will be the search key, that is the primary key, and the pointer to data field. And the next is index entry is created for first record of each block. First record of each block, that you call is a block anchor. And next is number of index entries. So whatever the index entries here, that should be equal to number of blocks. So here I created two blocks and the index entries are created 2. Okay, so this point should be noted. Number of index entries should be equal to number of blocks. Next point. So here the number of access required. So number of access to the blocks required blocks required is equal to log n to the base 2 plus 1. So this is the formula to calculate how many access are required, how many blocks we can access to find the required field, okay, required value. So number of access required, the index is accessing to number of blocks. The formula is log n to the 2 plus 1. Log into the base 2 plus 1. Here n you call it as number of blocks. Number of blocks acquired by index file. So here I am acquiring two index files. So number of blocks acquired by index file, that you call is n is represented as number of blocks acquired by index file. So why here we are putting 1 plus 1? So here the plus 1 is to reach to that particular record in log n to the base 2 block. Suppose here we are our value, whatever we are searching for the search key, that is present in this block. Okay, so only the starting record anchor block anchor will be there. Okay, so up to here it search log n to the base 2. Okay, so now we have our value will be present in this third place, in the second record, the third place. Here the value is present. So for searching for the next two records, we are two or more, means one step extra added. So that's why we are adding one more search plus 1. Okay, after reaching the block starting point, that is the log n to the base 2 is reaching to the starting point of a block, means starting record of a block. So to search for the required value in that block, you have to add plus 1. So that will be the formula for to access blocks required. Okay, so let us see one example. So here you can see the example. Actually, this primary index will be it's a dense index or a sparse index. Okay, suppose if you take the dense index. So I already said dense index means index entry. Index entry is created for every search key value. So here the index entry is created for every search key value. So here we have taken the search key value as account start. So this is the search key value. So you call it as a block anchor. Okay, block anchor. So this is a search key value. So in the dense index, we are creating search key for every search key value. Index entry is created for every search key value. Okay, so these are all the search key values. So we are creating index entries for every search key value. So here you can see this is one entry and this is one entry and this is one entry. Means like that we are creating index entry for every search key value in the data file. Okay, so this is your main data file and this is the index file. So in the dense index means we are creating an index entry for every search key value. We are not taking the starting one. We are creating an index value, index entry to every key. This you call it as a primary dense index. Now coming to the sparse dense, primary sparse index. So what is a sparse index? Means index entry. Index entry is created for only to some records. Okay, only to the some records. Means here the index is created not for all the records, only the first record of every block the entry is made. So here you can observe the search key value here is account. Okay, so this will be the search key value. I said this is the block anchor you call. So here the index entry is created only to this starting record of each block. Okay, so instead of searching all the key value entries in the index file, okay, this is the index file. So this is a key value key, and this is the pointer to the block. Okay, so A10 is a search key. So only to the starting of the record, starting record of the block will be entered in the index entry. Only starting record of the block is entered in the index entry. Okay, here also. So this you call it as a login to the base 2. Means up to you can calculate search login to the base 2. Okay, if you want to reach the particular file, particular record in the block, you just add +1. Means one more search to go for that particular record. Okay, so this is a primary sparse index. So instead of creating an index entry for every search key value in the primary sparse index, we are creating only the first record of every entry. Okay, so the index is created only for all the records. Only the first record of every block the entry is made. So for this block, the first record entry is made in the index file. So the first record of the block entry is made in the index file. The first record of this block entry is made in the index file, rather than entering all the search key values in the index file. So this is about the primary sparse index. So let us see the example. Okay, here the calculation. So see here. Let us take here we have to find the average number of blocks accessed with or without index. We want to search how many blocks. Okay, so here we have to find average number of block access with or without index. How we were calculating, let us see. Here the number of records are 30,000. Okay, so here the records we are saying that, so all records is up to 30,000 are there. Okay, and the block size is 1024. Okay, here the blocks, this is the hard disk. Okay, this is the hard disk, and here the blocks are there in the hard disk. So here the block size is 1024. They are saying only the size. Okay, size is 1024 byte, and the strategy they are following is the unspan. So what do you mean by unspan? I said unspan means a single record always placed in one block. In the last videos I said the span and unspan. Span means suppose if your record is half of the record is stored occupied this block and another half of the record is occupying another block, that you call it as a span. Unspan means only one complete record has to occupy one complete block, rather than dividing the record in one and another two. Rather than using the two blocks, one record should be occupy only one block. That you call it as unspan. So here also in this problem also they are following the unspan strategy. And the record size is 100 bytes. So for each record size they are saying 100 bytes. Here the block size is 1024 and the record size is 100 bytes. Now they are saying the key size. So key, why we are using the key? For searching the particular record. So index key size is 6 bytes. Okay, and the pointer size is 9 bytes. So the structure of index key consisting of key plus pointer. Okay, so here 6 plus 9 means the 15 byte size here. So index key size is 6 bytes, pointer size is 9 bytes. Now we have to find the average number of block access. So let us see. First, data records that can fit in one block. So in this one block, how many records we can fit? That we have to be calculated. Let us see what is the block size 1024. 1024 is a block size. Okay, how many records? What is the record size? Record size is 100. Okay, so 1024 by 100. So you will get the data record that can fit in one block. Total you get 10.24, but we have to take only the whole numbers because this is unspanned. Okay, so unspanned means only the records that are fit in one block you have to be taken. So that is 10 records. So one block you can place 10 records. So in each block you can place total 10 records. So in each block you can place 10 records. This is clear. Now coming to total records, they are saying 30,000. So total records are 30,000. So now total number of blocks. So how many blocks can be placed in the data file? Means in the hard disk. 30,000 by 10 records. You will get 3,000 blocks. Okay. 30,000 records are there. To store the 30,000 records, we require 3,000 blocks. So in each block, 10 records will be stored. Are you getting? Okay. Total 30,000 records are there. 30,000 records are there. So in each block, 10 records we can place. So how many blocks we have required? So total 3,000 blocks. 3,000 blocks. In each block 10 records. Total number of records are 30,000. Okay. Now coming to. So without index we can need 12 blocks to access finding the record. With index, okay, let us see size of index is 15. So I said key size 6 and pointer size 9. So total it should be 15. So size of index we get. So if you want to get the index record size or block size, 1024 is the block size. By index size, you get 68 because this is strategy is unspanned. Okay. So now the index records is equal to. We are finding the index for the searching of records and searching of the blocks. Index record is equal to number of data blocks is equal to 3,000. So we are having 3,000 blocks. Okay. So number of index blocks, we are finding the index blocks. So 3,000 by 68, we will get 45. So now to access the average number of blocks accessing, how many blocks we are accessing? Okay, so that is the log 45. So this is a formula, log n to the base 2. So n is the number of blocks searching. Okay, 45 plus 1 is the to reach to that particular record. To reach to the particular record, we are searching plus 1. So log 45 means 6 plus 1, you will get the 7. Okay, average number of block access is 7. This is how we are calculating the primary index. Thank you. Hi students, welcome back. Coming to our next topic, that is clustered indexing. So in the previous video we have discussed what is a primary indexing. In the primary indexing we say that the primary indexing should be an ordered file, and the next is the block pointer. In the same way, the clustered indexing is a non-key plus it should be ordered. So primary indexing should be ordered, as well as a cluster indexing is also in the data file, whatever the data file that the database is accessing. So that file should be ordered. So it is an ordered file with two fields, non-key. It is an ordered file with two fields, that is non-key and block pointer. Okay, so the index file means the index structure consisting of the non-key value and the block pointer. Okay, so actually the clustered is created on data files whose files or records are physically ordered on a non-key field which does not have a distinct values for each record. That field you call it as a clustering field. Means here ordering field of a data file. So if you take any data file, so which is ordered, have a distinct value for each record. So for each record, whatever that is there, we are accessing from by using the index file. Okay, so having the distinct value includes one index entry for each distinct value of the field. So this point you have to be noted in the cluster index. The main point here is we are using the non-key value. Okay, the search key value should be a non-key value, and it includes only one index entry. Okay, if you are having the multiple distinct values in the data file, even though the data file is having the distinct file, you are having only one index entry for each distinct file of the field. So let us see the example. Then you will understand what is the clustered index. Okay, so here you have taken a non-key and block pointer. So the values, the non-key A, B, C, D, E and F. So these are the non-key values. So let us take the data file. So the data file consisting of different blocks. So each block contains the three records A, B, C in one block. Another block contains C, D, E, and another block contains E, E, F. Okay, so this is the data file, and here this is the index file. So index file, you are having the non-key values 1, 2, 3, 4, 5, 6. So 6 non-key values are there. Okay, so these 6 non-key values will access the data file. So blocks on the data file. So here we are having the 3 blocks. So each block consisting of 3 records. Okay, so what it's saying is here A is accessing this block, B is accessing here, and the C will be found in this block. Okay, D in this block, E is in this block, and F is in this block. Okay, so here you just check here. It includes one index entry for each distinct value. Only here we are having two entries, 2 records. So with same value, the C is one record. Again in the another block, the C will be there. Okay, instead of entering the 2 multiples here, only one index entry for each distinct value. So with it's having 2 distinct values. Even though it is having 2 distinct value, only one entry is there in this block. Okay, only one entry, the C. Okay, in the same way here is also we are having the 3 entries. E. Okay, not 3 entries, 3 records are there in the blocks. So here is also we are having only one index entry for that E. Okay, only one index entry for these 3 records. It points to the first non-key value. So only whatever the non-key value that first appeared, it points to that only. Here is also, here we are having 2 C's. Okay, so whatever the non-key value that appears first in the block, that will be pointed. This is the clustered index. Even though you are having different distinct values, the index value is the index entry is only accept one index entry for each distinct value of the field. Here the ordering of the field of a data file have a distinct value for each record. Okay, and here there will be, you have to note it that there will be only one entry for each unique value of the non-key attribute. So this is the important note in the clustered index. So there will be only one entry for each unique value of the non-key attribute. So this is the cluster indexing. Here index entry is created for each distinct value. For each distinct value, first index entries are created. Okay. So, and then block pointers. These are the block pointers. So block pointer points to the first block where key is available. Means the non-key value is available. So the block pointer points to the first block where non-key is available. Here the type of index is used is a dense as well as a sparse. Both will be used. So now what are the accessing? Okay, average number of blocks access required. So what are the average number of blocks access required? In the primary index, you are having log n to the base 2 plus 1. Okay, log n to the base 2 is the number of blocks for accessing is required, and the plus 1 is to reaching to that particular record. So suppose here you got the log n to the base 2 up to here. To reach to the particular record, you are doing one more search. That's why it is plus 1. But here in cluster index, average number of blocks access required should be greater than or equal to log n to the base 2 plus 1. Why it is greater than or equal to log n to the base 2 plus 1? In the primary index, average number of block access required is equal to log n to the base 2 plus 1. Whereas here it should be greater than. Why it is greater than? Here you can observe. So in the index file, the entry should be less when compared to the data file. So in the data file, you are having the distinct values. So multiple files, records are there. Distinct value, repeating value. So C, C, E, E, E. Means that's why. So this data file may be greater than or equal to. It has to check more values. Okay. So instead of after completion of the C, the check the index entry is checking for, to check the another data file, data value, means the data record. So instead of going to here, it is skipping to D. Okay, after D, the index entry goes to the next record, that is E. So here already 3 E's are there, means 3 different distinct values will be there. So it's shifting the search to F. Okay, means the searching will be increasing. Here the greater than or equal to log n to the base 2 plus 1. Okay. So here the data file consisting of more records than in the index entry.
Okay, students, see to that the pandemic situation is increasing day by day, and nowadays more number of death tolls are recorded on a particular day. Okay, so see to that you all be in a safer side, as well as don't move unnecessarily from your homes. Stay in your homes and take the precautionary measures, and wash your hands regularly, as well as take the medicines whatever is needed, as well as you can take the homeopathy medicine also. So it's giving somewhat a positive response, and Ayurvedic medicine also. Okay, many people are suffering here and there. So beside your house or opposite your house. Okay, many peoples are affected. So see to that you are being very cautious about these disease. Okay, and many of them are moving to hospitals. So see to that if possible you help them at whatever the manner it's possible. Okay. Okay. So the next, wear your mask regularly. Without mask, don't move from your home. Okay. So be safe. That's what I want to say. And another thing, the classes will be hereafter. It will be reduced somewhat. So don't worry. So we know the practical difficulties which we are all facing here. Okay. So be safe. And hereafter the sessions will be reduced as of DBMS will be concerned. Okay. Okay. Take care of you. Thank you.